Oops. Okay. Let me just get rid of a few things here. Okay. So last time we finished off section. Yes. If you look. Okay. So if you look in educosoft.org, you can find the URL to yesterday's lecture in the announcement. I also emailed it to you. You can also find the recording of it if you go to cccconfer.org and click on recording. You can also find it there. Okay. So yesterday we did section 15.1, which was on mathematical induction. So let me start section 15.2, which is on sequences. So a sequence is just a function, and maybe I'll just call it A, which has as its co-range the natural numbers, okay? Or at least something that is isomorphic to the whole numbers, to the natural numbers. So, um, as I say, a sequence is just a function. And so rather than using functional notation, so notation, so we do not use functional notation. Okay, so rather than saying like a of 3 is 17, we instead use a subscript. So we'll say a sub 3 is 17. So, and rather than just writing, you know, a sub 1 is 12, a sub 2 is 14, a sub 3 is 83 or whatever, we will instead write that A is the sequence, 12, 14, 23. And so this means that, well, the value of A at 1 is 12. The value of A at 2 is 14. The value of A at 3, oh, I said 83, is 83. Or that the A sub 1 is 12, A sub 2, 14, A sub 3, 83. Or we can think of this as the first term, 12, second term, 14, third term, 83. And so, in an infinite sequence, is a sequence such that the domain is actually the set of real numbers is called an infinite sequence. Okay, and so an example of an infinite sequence is 1, 1, 2, 3, 5, 8, 13, 21, 34, etc. This actually has a name. It's actually called the Fibonacci sequence, and it goes on forever. Uh, if your sequence is not infinite, then it's called a finite sequence. So a finite sequence is, well, a sequence that is not infinite. Is said to be a finite sequence. So it's just going to have a finite number of terms. So an example of that, of a finite sequence, is a sequence, I don't know, 2, 3, 8, 17. So that is an example of a finite sequence. Let me do some examples. Let's say on page 641. Let me do problem number 1. 2, 5, 8, 11, dot, dot, dot. Now, these dots here are called ellipses, and this just means continue with the same pattern. Okay. In exercises 1 through 6, identify a pattern for the term of the sequence and write the next 4 terms. So let's write the next 4 terms. Well, to go from from 2 to 5 to 8 to 11, well, it seems like you're always adding 3. So the next would be 14, then 17, then 20, then 23, etc. So that's the next 4 terms of this sequence. Okay. Let's do problem number 3. 3, 8, 13, 18, 23. Okay, so if I look here, well, it seems like I'm always adding 5 to go from 3 to 8. Add 5 plus 8 plus 5, 13, plus 5, 18, plus 5, 23, plus 5, 28, plus 5, 33, plus 5, 38, plus 5, 43, etc. So that's the next 4 terms. Let me do problem number 5. 1, 3, 927. Okay, so multiply 1 times 3, 3 times 3, 9 times 3, 27 times 3, 81 times 3, 243 times 3, 729 times 3, I think, dot, dot, dot. It's so, let's see. So multiply by 3. Hopefully I'm right. So 27 times 3, 81 times 3, 243 times 3, 729 times 3, 2187. Okay, good. Let me do problem 7. 1, 3, 5, 7, etc. Here it says to find the fifth term. Okay, so let's do that. In exercises 7 through 16, determine the indicated term of the sequence whose first few terms are given. Okay, so I'm given the first 4 terms here explicitly. Now I want to figure out the fifth term. Okay, so I add 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9. And that is the fifth term. Let's do problem number 9. 1, 0, 1, 0, 1, 0. It's, oh, I'm sorry. I wrote it wrong. 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, and you want to find the 18th term. Okay, so let's see. First, second, third. Well, let me write these down. So this is the A1, A2, A3, 4, 5, 6, 7, 8, 9, 10. Okay, so then it goes, there's 4 zeros, 1, 2, 4 zeros, then a 1, so 11, 12, 13, 14, 15, and then there'll be 1, 2, 3, 4, 5, and then 16, 17, 18. And so the answer is 0. So the 18th term in this sequence is 0. Okay, let's do problem number 11. 1, negative 1/2, positive 1/4, negative 1/8, positive 1/16. You want to figure out the 10th term. Okay, so let's do that. So 1, negative 1/2, 1/4, negative 1/8, positive 1/16. So first, second, third, fourth, fifth. Okay, so notice I keep alternating signs, so I keep multiplying by negative 1/2. And so I get a negative 1/32, positive 1/64. That's 6, 7, negative 1/128, 8, positive 1/256, 9, negative 1/512, 10. And so my answer is a negative 1/512. And that is the 10th term in this sequence. Any questions about that? Okay. Let me do problem number 13. One, 3, 8, 16, 27. Yes. What does this tell us about the sequence? That just, right now, that just tells us what the particular term is of a sequence. Okay. Eventually, when we have some particular uh, sequences, we'll actually be able to give you a formula for that particular sequence and tell you what the form is of the general term for a sequence. This is just basically telling us what the value of a function is at a particular point. Okay, so 1, 3, 8, 16, 27. Find the 7th term. Okay, so, so this is going to be, that's 3, Q4, 2. Okay, wait 1 second. 8, 16. Okay, so you add 5, you add 9, you add 11. Okay, so I add 2, 5. So I'm adding 2 here, then 5, then 8, then 11. Okay, no. 1, 2, 3, 4, 5, 6, 7. Threes. I can't find the pattern uh, with 3 spaces. I can't. This is 2 cubed. Okay. 3 space between the spaces. Layered. Okay, so here, wait. Oh, meaning do it twice, maybe. So it goes 2, 5, 8, 11. So that's 3, 3, 3. Okay. So 3, then you get a 14. Almost encryption. Yeah, I know. Okay, so yeah, that's it. So so to go from 1 to 3, you add 2, and then from 3 to 8, you add 5. So that's 3 more. And if you do 3 more than that, then that's 8, which you add to your 8 to get 16. And then you add 3 more, which is 11, okay, to get the next one. And so 3 more would be 14. And so you'd have a 1, 3, 8, 16, 27. Now this is too crowded. And so that means you're going to add 14 to this guy. So that would be 30, 41. Now add 3 more, which is 17, which is 58. So this is the first, second, third, fourth, fifth, sixth, seventh term. So the seventh term should be 58. Okay, good. Uh, 15. Okay, so 15. Maybe I should do that. Okay, yes. Okay, so that's how you get to the next ones. Okay, 15. 1, -2, -5, -8. I want to find the eighth term. Okay, so if I look at this, well, I'm going to keep adding negative or subtracting 3. So I get a -11. So that's a 1, 2, 3, 4, 5th, 6th, 7th, 8th term. So I keep subtracting 3 from each of these, 14, 17, 20, to get to -20. Mm-hmm. 17. Yes, that's it. So problem number 17, just looking at patterns basically for right now. In exercises 17 through 22, write the sequence in function form. Okay, so I have a 1, 1/4, 1 over 16, 1 over 64. Okay, so that says that the first term, and maybe I'll call it f because it's a function. So the first term is 1, the second term is 1/4, the third term is 1/16, the fourth term is 1 over 64. I want to figure out what is the nth term? Well, maybe I'll call it n because it's a natural number. So what does that equal to? Well, notice to go from one to the next, I keep multiplying by 1/4. Okay, so this is the same as 1/4 to the first power. This is the same as 1/4 squared. This is 1/4 cubed. This is 1/4 to the 0 power. And so notice that, well, for 1, you get a power of 0. For 2, power of 1. 3, a power of 2. 4, power of 3. And so what you're doing here is just subtracting 1 from each of these values in the exponent. And so f sub n should just equal 1/4 to the power n minus 1. And that is the function that gives me all of these values in that particular sequence. It's nice to box and answer always so that you know that that's what, the question is asking. That's the answer to the question. It's always good to do that. 19. We will be, these are, I can graph them, but for right now, we just want to look at them as a function. If you look at them graphically, they're just going to look like, ooh, wait. They're just going to look like a whole bunch of dots on the plane. Let me ask you, can you still hear me? Please don't disconnect me. Um, yes, you can you see the writing in the background still? Can you see the writing in the background? Okay. Yeah. 1 second. Can you see it now? Yes. Okay. Sorry about that. 19, 5, 8, 11, 14, 17, etc. So let's try to find the function form for that. So f of 1 is 5. F of 2 is 8. F of 3, 11, 14, 17. So notice I keep adding 3. Well, actually, I don't add anything here, but I add 3 to get to the next one. I add 3. Well, actually, I added 6 to 5 to get to 11, and I added 9 to 5 to get to 14, and I added 12 to get to 17. So I want to figure out what f sub n is. Well, let's see. If I notice, that's 1, 3. Then this is actually no 3s. This is 2 3s. This is 3 3s. And this is 4 3s. And so, no, I notice that again, this is 1 less than that value that I'm evaluating at. And so for each of these, it's just equal 5 plus 4 minus 1 times 3, 5 plus 5 minus 1 times 3. They're all the same. Oh, I see. I wrote 3, 4, 5. Yes, I see. That was a typo, obviously. 1, 2, 3, 4, 5. Okay, so um, therefore, if I look here, well, it's always 5 plus whatever value I'm evaluating at minus 1 times 3. And that is your answer. Let me do 21. Yeah. So, well, that was a pattern. The pattern was that you kept adding 3 to every term. So 5 plus 3, 8 plus 3, 11 plus 3, 14 plus 3, 17. So you kept adding 3. Let me do problem number 22. Well, that's what the pattern gave us. The pattern gave us that if I kept adding 3 to each side, then the function form came out to equal, well, what you start out with plus some multiple of 3. 22. 5, negative 10. And actually, this will eventually have a special name to it, and we will determine its general term. And it'll actually look like what I've just written. Okay, so let's figure out the function form for this. So f of 1, 5, 2, negative 10, 3, 15, 4, negative 20, okay, and we want to figure out the value of f at n, okay. We don't really need that page. So yes, so for right now, we're just looking at a pattern. But in the next chapters, the next sections, we'll have some particular types of sequences, and I'll be able to give you the general term. So I'll tell you what the function form is for each of them. Okay, so notice that this is just equal to, well, 5 times negative 2. Actually, so this is 5 times 1. This is 5 times negative 2. This is 5 times 3. This is 5 times negative 4. Okay. And so this is equal to, well, 5 times 2, but you have a negative 1 times 5 times 2. You have here a positive 1 times 5 times 3. So that means an even power. And I can find an even power by just, let's say adding 1 to this to get 4. So I can do an odd power by just adding 1 to this. So I can again get an even power by adding 1. Right, so the alternating sign. Sometimes they're positive, sometimes they're negative. And so now I have 5 times 4, but time a negative. So that means I want an odd power. So I can just add 1 to get to an odd power. And so if I look at this, oops, didn't need that extra page. If I look at this, well, this is always equal to negative 1 to the power. I just added 1 to each of those values that I was evaluating at. And then I multiplied by 5 times whatever value I was evaluating at. And so f of n is equal to a negative 1 to the n plus 1, let's say, times 5n. And that is the function form for that particular sequence. So that really finishes off section 15.2. Let me go on to section 15.3. Okay, so section 15.3, arithmetic sequences. Okay, so suppose we have the following sequence: 8, 11, 14, 17, 20. Okay, notice that if I add 8 plus 3, I get 11, plus 3, I get 14, plus 3, I get 17, plus 3, I get 20. Oh, why does it keep doing that? And so, good, it didn't switch anything. So, if I look at 11 minus 8, I get 3. 14 minus 11, 3. 17 minus 14, 3. 20 minus 17, 3. So that means that an arithmetic sequence, this is called an arithmetic sequence. So in an arithmetic sequence, the difference between consecutive terms is always equal to the common difference. So some constant called the common difference, denoted by D. Okay, so an arithmetic sequence is defined recursively as some sequence where to find the next term, we always add some constant D. And so if a sub n plus 1 is always equal to an plus some constant D, then we say that it is an arithmetic sequence. Okay. So let me give you the formula for the nth term of an arithmetic sequence. And so I have that a sub n is equal to a sub 1 plus n minus 1d. Yes, so this is, notice that in the previous thing that we did, right here, matter of fact, it's right here, that this is an arithmetic sequence. So actually I had an arithmetic sequence here, and for that arithmetic sequence, I actually derived the formula that I'm giving you in that particular case. And so yes, it is the I wonder why that's taking time. It is the function form. It is the general term for a arithmetic sequence. Okay. Okay, so let's show this. And let's show this by, I want you to know the important thing is to know the this formula here. Okay, or at least know how to use the formula. Okay, so let's prove this by induction. So first let's look at the initial case. And so for n equal to 1, I get that a sub 1 plus, 1 minus 1 is 0, is equal to a1. So therefore, I've shown that for the case n equal 1, this works. Good. So let's do the inductions. So the induction case. So let's assume that a sub n is equal to, or let's do it for k. Let's assume that a sub k is equal to a1 plus k minus 1d. Then I want to show that this formula works when I replace n by k plus 1. Well, let's see. A sub k plus 1 is equal to, well, from here, a sub k plus d. And, well, a sub k from up here is equal to a1 plus k minus 1d. And, well, I'll have to add the d from here. multiply d inside the parentheses. So this is equal to A1 plus KD minus D plus D, which is A1 plus KD. Let me write K as K plus 1 minus 1. So I've really done nothing. I just added and subtracted 1. And let me put a parentheses around this. But now that says that AK plus 1 is equal to A1 plus K plus 1 minus 1 times D, which is just the same as this formula here, where I've replaced N by K plus 1. And so I've shown the induction case. So therefore, by the principle of mathematical induction, so this is an equation. This is a formula. Okay, so this here is a formula, a literal equation. So by the principle of mathematical induction, AN is equal to A1 plus N minus 1D for all natural numbers N. So I'm done. That's what I wanted to show. Okay, so let's do some examples. Let's say on page 648. Oh, that means I'm done. Quod erat demonstratum, and thus it has been shown. It just means I'm done with what I'm with the proof. It's just that basically this says start and this says finish. So that's just the notation for start and finish. So on page 648, let me do problem number 1. In exercises 1 through 5, find the first 5 terms of the arithmetic sequence using the given information. So the first term is 2. The common difference is negative 1. And so now I want to figure out, this is page 648. Okay, so the first term is 2. Let's add negative 1 to it. So 2 minus 1, 1. Subtract 1, 0. Subtract 1, negative 1. Subtract 1, negative 2. And it's the first 5 terms. And so I am done. Let me do problem number 3. The first term is 0. And the common difference is 4. So the first term is 0. Add 4. Add 4. Add 4. Add 4. And you are done. Problem number 5. The first term is 3. And the difference between The fifth term and the fourth term is 2. Well, that implies that the common difference is 2 because those are consecutive terms and this is an arithmetic sequence. Therefore, first term is 3, add 4, add 2, sorry, add 2, add 2, add 2, add 2, etc. Let me do problem number 7. The eighth term is 21 and the 15th term is 35. In this case, actually, I will be plugging into little equation now. But no, all I was doing is using the fact that an arithmetic sequence is defined as being such that you always add the common difference to get to the next term. So I was just using that fact. I wasn't even using a formula. I kept adding the common difference. So I was not even using a formula. I was not using a formula. All I was doing is adding the difference. So I kept adding 2. I kept adding 4. I kept adding -1. Okay? So I was not using a formula. I was using the definition of an arithmetic sequence, which was you always add the common difference to get to the next term. Now, they will tell you. So in the question, here it says in exercises 1 through 5, find the first 5 terms of the arithmetic sequence using the given information. In general, you should write as many terms as it takes to determine the pattern. The minimum really is 3, but you may have to have more than that. But certainly 3 is the minimum that you would need. Okay, in exercises 6 through 9, write the first. Oh, except I wrote the wrong thing, didn't I? 21:35. In exercises in exercises 6 through 9, write the first 3 terms of arithmetic sequence using the given information. Okay, so let's do that. Now I'll just write the formula for the general term. So now I'm going to use this equation. So I know that in general, since this is an arithmetic sequence, that in general the nth term of arithmetic sequence is just the first term plus n minus 1 times the common difference. Okay, so let's use these to solve this. Well, the 8th term, meaning that n is 8, is just equal to 21. The 15th term, meaning n is 15, is just 35. Okay, so this was a sub 8. This was a sub 15. And so I have that a1 plus 8 minus 1 is 7d is 21. And a1 plus 14d is 35. Let's call this R1. Let's call this R2. Now notice I have two equations with two unknowns. I don't know A1, nor do I know D, but I have two equations. So I know how to solve two equations and two unknowns. I'll just do, let's say, minus R1 plus R2. And so I have a minus A1 minus 7D is a negative 21. And I have A1 plus 14D is 35. Let's add these. So I get A1's cancel. 7D is 14. So divide by 7. Maybe I'll do that. Divide by 7. And so I get that D is equal to 2. Good. Now all I have to do is figure out A1. So let's use R1, let's say. Well, I know that A1 plus 7D is 21. So A1 plus 14 is 21. Subtract 14 from both sides of your equation. So A1 is equal to 7. Okay, and I want to find write the first three terms. So let's write the first three terms. And so the first term is 7. And, well, the common difference is 2, so I'll add 2 to it. 9, add 2, 11, etc. And so those are the first three terms of this particular arithmetic sequence. Let me do problem number 9. This is a formula so that you can figure out the general term for any sort of arithmetic sequence. And so this just gives you it's the same as saying y equal mx plus b. It's just a literal equation, meaning that once you know, say m and b, then you're able to figure out the equation of a line. Once you know a1 and d, you can figure out the equation of a arithmetic sequence. You can figure out every term of an arithmetic sequence. Let me do problem number 9. The 11th term is 2. The 21st term is 7. Okay, and you want to figure out the first three terms of the arithmetic sequence. Okay, so again, the nth term is just a1 plus n minus 1d. Well, the 11th term is 2. And that's just, I don't know a1. I know, however, that n is 11. The 21st term is 7. I don't know the first term, but I do know that the nth term, that n is 21. And I don't know the common difference. And so I get two equations, just like before. A1 plus 10d is 2. A1 plus 20d is 7. Okay, so let's do negative R1 negative a1 minus 10d is negative 2 plus r2. a1 plus 20d is 7. And let's add. So the a1's cancel, so I get 10d is 5. Divide by 10, and so d is 1/2. Okay, so let's figure out, let's use R1. So it says A1 plus 10D is 2. So A1 plus 5 is 2. Subtract 5 from both sides. So that says that A1 is negative 3. And so the first term is negative 3. Add 1/2. So you get negative 6/2 becomes negative 5/2. Plus 1/2 is negative 4/2, etc. That is the first three terms of that arithmetic sequence. Let me do problem number 11. Because the first term is negative 6/2. Add to that 1/2. 1 minus 6 is negative 5. Add to that negative 1/2. 1 minus 5 is a negative 4. 6 divided by 2 is 3. 4 divided by 2 is 2. And that is your sequence. Okay? Let me do problem number 11, which is negative 1, 1, 3, 5. In exercises 10 through 15, find the general term of the arithmetic sequence. Okay. And so the general term for arithmetic sequence is just a sub 1 equals a1 plus n minus 1d. Well, in this case, the first term is negative 1. The common difference is you keep adding 2. And I'm done, but maybe I'll multiply the 2 inside the parentheses. And so a1 is equal to a negative 1 plus 2n minus 2. And so a sub n equals 2n minus 3. And that is the general term for this particular arithmetic sequence. This is an explicit formula, yes. In this particular case. Okay. Okay then, so let me do problem number 13. Negative 3 0, 3, 6. Okay, so again, I want to find the general term. Well, I know that the general term for any arithmetic sequence is a1 plus n minus 1d. You're finding the general term for arithmetic sequence, meaning you're finding the function. I'm asking you to find a function. Okay, what is the rule that you have to find a term in in this particular arithmetic sequence? Okay, so the first term is, well, negative 3 to go to each subsequent term. I keep adding 3. And so negative 3 plus 3 is 0, plus 3 is 3, plus 3 is 6. So the common difference is 3. Again, I'm done, but I might as well multiply the 3 inside the parentheses. So a sub n is equal to negative 3 plus 3n minus 3. So therefore, this is just equal to 3n minus 3 is a minus 6. Okay. Let me do problem number 15. 15, 27 over 2, 12, 21 over 2. Let me write this as follows. 15 is 30 over 2, 27 over 2. Let's write 12 is 24 over 2, and then I have a 21 over 2. Just so you can see a little bit easier what's going on here. And so let's find the general term. A sub n is a1 plus n minus 1d. Just getting a common denominator. Actually, it just looks like a whole bunch of points. So in general, a sequence looks like a whole bunch of dots on a graph. In this case, an arithmetic sequence will look like a whole bunch of points along a line. And I will be doing that in problems 31 through 34. Okay, so a sub n is equal to a1, which is 15, plus n minus 1d. So let's figure out the common difference. Well, notice 30 to 27, subtract 3, to 24, subtract 3, to 21, subtract 3. So the common difference is a negative 3 halves. Oh, actually, maybe I should write this as 30 over 2, because I need a common denominator anyway. So let me multiply negative 3 halves inside the parentheses. And so I have a sub n is equal to 30 over 2 minus 3 halves n. Minus and a minus become a plus 3 halves. Therefore, a sub n is equal to 30 plus 3, 33 over 2, minus 3 over 2n. Well, they got a common denominator, so I might as well write it as 33 minus 3n all over 2. And that is the formula for the general term of this particular arithmetic sequence. Okay. Any questions about that? Okay. Yes, I'll be showing you that a little later. Okay. Okay, good. Okay, so let me do problem number 17. Well, actually, before I do that, let me ask you the following. What is the average of 4 and 8? Well, to find the average of 4 and 8, you would just add them, divide by 2. And so the average would be 4 plus 8, 12 divided by 2, which is 6. So the average of 4 and 8 would be 6. Okay. So if I look here at 4 and 6, 4 and 8, all I'm doing is just adding them and dividing by 2. Or another way of looking at this is that if I look at the numbers 4 and 8, then I put the number 6 in between, notice that this becomes an arithmetic sequence. And this number here is called the arithmetic mean. Okay. So in statistics, this little notation I've given you here is actually what is called the arithmetic mean in statistics, or the mean in statistics, which is found by just adding up all your numbers and dividing by however many numbers you added up. It's the usual idea of average. Um, or in this case, since we're talking about arithmetic sequences, it's really just forming an arithmetic sequence out of the given numbers and using those. No, it's not like that factorial at all. Um, and so this is just like constructing an arithmetic sequence where the first, the two terms that are given are the first and last terms of that particular arithmetic sequence. Okay, so let me do problem number, what was I on now? 17. Let me do problem 17. Find, in exercises 16 through 19, find the arithmetic mean of the numbers. So let's find the arithmetic mean of these numbers. So I'll do it two ways. So the first way is, well, I'll just add these two numbers and divide by 2. 2 divided by 2 is 1. And so the arithmetic mean is 1. Okay, or let's do it a different way. Suppose I have negative 5 and 7. Why not negative 12? Because you're adding. 7 minus 5 is 2, not 12. Okay, so suppose that I want to insert an arithmetic mean. meaning I'm going to make this into a sequence. So this will be an arithmetic sequence. Where in this case, I've inserted one number in the sequence. Okay, so let's figure out what this is. Well, in general, a sub n is a1 plus n minus 1d. I know that the first, second, third term is 7. I know the first term is -5. I obviously know what n is because it's the third term. But I don't know the common difference, but I can find the common difference from this. This is problem number 17. Okay, and so I get that 7 is equal to -5 plus 2d. Add 5 to both sides of your equation. And so 12 is equal to 2d. Divide both sides of your equation by 2. So d is equal to 6. And so let's figure out the sequence here. So the sequence is, well, the first term is -5. Add to it 6, you get 1. Add to it 6, so you get 7. Therefore, that says that the arithmetic mean is 1. That term in the middle here is 1. And so you can do it either way. You can just add up the numbers, divide by 2, or you could use the above given formula for the general term to find the arithmetic mean. Let me do problem number 19. 19 halves, 35. So let's find the arithmetic mean. I'm just going to add these and then divide by 2. I'm not going to do it the other way. Oh, no, but it works the same. That's correct. So the answer is certainly, notice in problem 19, I'm just going to do it the simpler way. And so this is the same as 19 over 2 plus 35 divided by 2. Let me multiply and divide by 2. And so I get 19, the 2's cancel, plus 70 over 4. And so this is 89 over 4. And that is your answer. So that's your arithmetic mean. So for these problems where there's only two numbers, where you're only inserting one arithmetic mean, it is certainly easier just to add them and divide by 2. And that's certainly an acceptable way to do this. You can also do it on your calculator, yes. However, it is preferred that you do not give that answer because you started with a fraction, therefore your answer should be a fraction. So you have to convert that from a decimal to a improper fraction because the numbers were given as improper fractions. So recall that if you're given a problem in one form, then your answer should also be in that same form. Okay? So the form given was 19 over 2. So it should be written as a improper fraction. Okay. Let me do problem number 21. So now you don't want to insert 1. So it says insert 5 arithmetic means between 3 and 10. So now I'm going to have to use that the second type, the second way that I did this, uh, in this previous example, on inserting arithmetic means. So I start with 3. I want to insert 1, 2, 3, 4, 5 arithmetic means. So 1, 2, 3, 1, 2, 3, 4, 5 arithmetic means. And so a 2, 3, 4, 5, and 6. So I'm going to insert 5 arithmetic means. So I want that this is an arithmetic sequence. Well, luckily, I know that the general term for arithmetic sequence is just a1 plus n minus 1d. I know that the first term is 3. I know that the seventh, so notice this is the seventh term here, is 10. And I notice that n in this particular case is 7. I don't know d, but I can certainly, there's only one variable to solve for, so I can certainly figure that out. So I know that 10 is equal to 3 plus 6d. 1, 2, 3, 4, 5, 6, 7. Yeah, that's 7. Oh, well. Okay. And so it's going to not be such a nice number. And so I have subtract 3 from both sides. So 7 equals 6d. Divide by 6. I should have inserted 4 instead of 5. It would have been nicer. Okay, and so d is equal to 7 over 6. What does that mean? Is that when I do a new addition, I will change the problem. Okay, so it's a note to myself. Okay. Um, okay, so let us do the following. So the first term is 3, which is the same as, notice, 3 is the same as 18 over 6. So let's add 7 over 6. So it gives me 25 over 6. Add 7. So that gives me 32 over 6. Oh, maybe I'll write the 3 here originally as 18 over 6. just multiplying, dividing by 6. And so this says that I'm going to add 7 over 6 to each term to get to the next term. And so let's add 7 over 6, 39 over 6. Add 7 over 6, 46 over 6. Add 7 over 6, 53 over 6. Add 7 over 6, 60 over 6. Okay, so this is equal to you add 7. Keep adding 7. Eighteen plus 7 is 25. Plus 7 is 32. Plus 7 is 39. Plus 7 is 46. Plus 7 is 53. Plus 7 is 60. Okay? So now let's reduce this. So 18 divided by 6 is 3. Well, I can't really reduce 25 over. I can divide. You kept adding 7. Add 7. Okay. 32 over 6. Well, again, I can reduce that as divide each by 2. 16 over 3. 39 over 6, I can divide by 13. That's 3 over 2. 46 over 6, I can divide by 2. So that's 23 over 3. Can't really do anything with 53 over 6. And 60 divided by 6 is 10. So if you reduce each of these, you get the following sequence. Oh, and so let me undo each of those. Undo, undo, undo. Okay, so this says that the arithmetic means are 25 over 6, 16 over 3, 3 over 2, 23 over 3, and 53 over 6. Okay? And those are your arithmetic means. Actually, it looks easier when I put them all over a common denominator. Then it looks like a nice, easy pattern. But of course, usually they reduce them at the end. But if you leave them in unreduced form, leave the 3 as 16 over 6, the 10 is 60 over 6, and write everything under the common denominator of 6, it looks nicer. Okay. What was the original question? So the original question was insert 5 arithmetic means between the numbers 3 and 10. And so we found those 5 numbers, which made this sequence into an arithmetic sequence. So I inserted these 5 numbers to make to make this an arithmetic sequence. Those are called arithmetic means. No, those are the 5. So the 3 and 10 are part of the sequence, the arithmetic sequence, yes, but they are not part of the. They're not the arithmetic means that we inserted. Okay, let me do problem number 23. Number -1, 10, 21, 32, all the way up to 186. In exercises 23 through 28, find the number of terms of the arithmetic sequence. Okay, so I want to find how many terms are in this particular arithmetic sequence. Okay, and so I know that okay, so um, we'll actually be giving you a whole bunch of uh, examples of these sequences and all that in the real world, dealing with money and mortgages, dealing with credit, loans. Uh, but let me get through this first. Yes, money. Yes, that's right. Ultimately, a lot of these come down to money. Um, and so in exercises 23 through 28, find the number of terms of the arithmetic sequence. Okay, so I know that an arithmetic sequence is a sequence in the following form. Well, I don't know what n is, but I do. So let's say that I'm going to find it. So I don't know what n is, but I'm going to say that n is the last term. And so I will say here that n is 186. For some n, and I'm going to figure out what n that is. Well, I know that the first term, oops, I know that the first term here is -1. I don't know n. That's what I'm trying to find, but I do know the common difference, right? The common difference, well, what do I have to keep adding to get to the next term? Notice that, okay, there. Notice that I keep adding 11 to get to the next term. And so -11, -1 plus 11 is 10, plus 11, 21, plus 11, 32. So I keep adding 11. Um, the recursive definition will not help in this case because it'll have too many unknowns. And so if you tried to use it, you could, but you'll find that it will be easier to use this general form. So the recursive definition, yeah, you could use it, but I'm trying to give you something simpler to use. Yeah, this is much easier. Okay, so let's do this. Let's multiply the 11 inside the parentheses. So I get 186 is equal to -1 plus 11n minus 11. Eh, something close to that, maybe. The answer is yes, but close. But that doesn't always work. It's just because you start out near 0. Um, so let's do 186 is equal to 11n. -1 minus 11, -12. Let's add 12 to both sides of my equation. What's the definition of A? It's just the name of the sequence, right? It's a name. Uh, I could have called it anything. We just usually use that. It's like saying, what's the definition of X? Well, it's a variable. It's a name of a variable. F is the name of the rule, the function. Okay, so yeah. Um, so actually, A is the function. You could think of it as the dependent variable, but it's usually considered the rule, the name of the rule. So 198 equals 11n. Divide both sides of your equation by, yes, by 11. And so n in this case is equal to 18. And so there are 18 terms in this sequence. Let me do problem number 25. 8, 15, 22, 29, 120. And so again, these are just sequences of numbers. Okay. They may have applications, but a sequence is just a sequence. Okay, so the general term for arithmetic sequence is an equals a1 plus n minus 1d. I know that the nth term is 120. The first term is 8. I don't know what n is, but I know that the common difference is 7. Is 7. So I know that 8 plus 7, 15 plus 7, 22 plus 7, 29. And so the common difference is 7. Let me multiply 7 inside the parentheses. And so 120 is equal to 8 plus 7n minus 7. So 120 is equal to 7n plus 1. Subtract 1 from both sides of your equation. And so 119 equals 7n. Yes. And so divide both sides of your equation by 7. So n is equal to 17. So there are 17 terms in this sequence. 27. So let's do problem number 27. -4, 10, 24, 38, 206. Okay, so again, the general term of this arithmetic sequence is A1 plus n minus 1d. Yes, that's right, just like all the previous ones. And so the nth term, we'll call the nth term the last term, oops, which is 206. I know the first term is negative 4. I don't know n, but I do know the common difference is 14. Negative 4 plus 1410 plus 1424 plus 1438. Let me multiply 14 inside the parentheses. So, um, what's 24 minus 10? 14. And so that's the common difference. So if you take the difference of two consecutive terms of this arithmetic sequence, you'll get the common difference. And so 206 is equal to a negative 4 plus 14n minus 14. And so 14n minus 18. So let me add 18 to both sides of my equation. And so what about negative 4 and oh, it's the same thing. 10 minus a negative 4 is 14, right? And so notice that no matter how you slice it, you keep getting the same number. Okay? Okay. So, um, 206 plus 18, 224 is equal to 14n. Divide both sides of your equation by 14. So n is equal to 16. So there are 16 terms in the sequence. Um, there are, well, uh, there are a lot of stories about sequences and all that, but especially Fibonacci. Um, so you can read up. You can read up on them. Okay, 29. Negative 1, 2, 5, 8, 11. In exercises 29 through 34, draw the graph of the arithmetic sequence. Okay, so let's draw the graph of this. And so let's see. So probably about here. Hopefully that'll give me 11. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that'll give me 11. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is, I can call it X and Y, don't really need to. And let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't really need negatives here, but I'll still draw, put tick marks here. Y dots, and so, well, you'll see right now. Okay, so now, um, this says that the first term is negative 1. This says the second term is 2. The third term is 5. So 2, negative 1, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is the first number, second, third, fourth, fifth, 1, 2, 3, 4, 5. That's all that we have. So second number is 2, third number is 5, fourth number is 8, fifth number is 11. So what you, well, doesn't quite look good, but what you should notice um, is that they go along a straight line. Let me, okay, there. Now it looks straighter. And so what you do notice is that each of these are points along a line. So this is the point 1, negative 1, 2, 2, 3, 5, 4, 8, 5, 11. So the first number here is actually the position. So this is its position in the sequence. The first number, the second, the third, the fourth, the fifth number. This is its value in the sequence. Okay? No. This ordered pair, these points on the plane indicate, well, the first coordinate is just the position in this sequence. The second coordinate is just its value. And so this is the first, second, third, fourth term, and the fourth term is 8. And so this says that the fourth term has a value of 8. The fifth term here has a value of 11. Okay? Let me do problem number. Yes, so its position in the sequence is first. It's the first number. So its position is 1, but its value is negative 1. So the position is 1, but its value is negative 1. Okay? Let me do problem number 31. 0, 1.5, sorry, 3, 4.5, 6. Okay? And so, and that's why it's dots. That's correct, because it's just a sequence. So its domain is just some subset of the natural numbers. So its domain is just these points, which are natural numbers, the counting numbers, because I'm counting their position. Okay? And so notice in this case, this is the first position, second, third, fourth, fifth. This is the first, second, third, fourth, fifth number. Yes, it is well, all functions are just, any relation is just a set of ordered pairs. Okay, so let's do this again. And well, I don't really need too much here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. So at 1, it's 0. At 2, it's 1.5. At 3, it's 3. At 4, it's 4.5. And at 5, it's 6. Okay. And I guess I'll just call them X and Y. Again, X meaning the position, and Y meaning its value. So at 3, 1, 2, 3, it's 3. At 4, it's 4.5. At 5, it is 6. So notice, actually this one looks a little better. They all line up on a straight line. Yeah, so this is basically functional notation. Yeah, just like in all the a regular sort of graph that we've done in the previous chapters. Let me do problem 33, and that'll be the last problem. So 33, -3, 0, 3, 6, etc. So again, this is the first number, second, third, fourth number. Okay. Oops. I don't need a new page. Oh, come on. Okay. 1, 2. That's going to be okay. Let's go like it over here then. Okay. So X, Y. So I have enough. So 1, 2, 3, 4, 5, 6. That's my Y. Then for my 0, 1, 2, 3. Then for my X, 1, 2, 3, 4. They are coordinates. So the dots are found coordinate. So the first position, the first coordinate is the position. The second coordinate is the value. And so at 1, we're at -3. At 2, we're at 0. At 3, we're at 3. Oh, I see. This is kind of cockeyed a little bit. Okay. At 4, we're at 6. Good. There. And so notice, I had to sort of move it so it looked a little bit better. So notice that this, again, looks like it's on a straight line. So that's problem 33. So that finishes off section 15.3. And on Monday, I guess we'll go on with section 15.4. So that's it for